Oh, yes. This time I'm going to remember to press the stop recording. Yeah, here. All right, so for the second cross sections, first thing we got to realize is we have square cross sections. So the area of a square is nice. It's just our side squared. And if I make a volume, we'll have a dx. Now, x squared plus y squared equals 1. If you remember your conics, that's a circle of radius 1. Now, circle of radius 1 is really tiny. So I decided to make 10 be 1. So each of these is decimals, so we have a much better picture. Now, this one's actually a little bit hard to tell what you're really looking at, because I've got y equals 0, I've got x equals 0, it breaks us into 4 quadrants, but nothing tells me which quadrant we're really looking at. So we're going to change the problem slightly, because I made the problems in the first place be greater than or equal to each of these. So now we're just looking at our first quadrant. So we've got our first quadrant here. If this is my rectangle, what we want to envision here is squares coming out of the page. Here, let me see if I can draw that more on an angle. So we want to envision these as squares coming out of the page. And each square has this width. So as the squares go closer to the edge, the squares are going to shrink down a little bit. So each of these is coming out of the page, which is really kind of hard to envision. Now the good news is if you can't envision it, well, that's fine. We can still come up with the area. So this is our side squared. Well, our side is the whole side here, right? It's the top of our rectangle minus the bottom of our rectangle. So we're going to integrate this. Our side is, well, here's the problem. We can't just use the function because we got two variables in there. So what we have to do is we got to solve for y. So y squared equals 1 minus x squared. So y itself is plus or minus the square root of 1 minus x squared. Now the top half would be the positive version, and the bottom half would be the negative version. But since I don't want the negative half, I can just get rid of the negative half. We've got our square root. So the height of this rectangle is top minus bottom. So our top ends up being our square root of 1 minus x squared minus our bottom, which is 0. So that's very useful. Squared it because we have our side squared, dx. And our bounds are going to be from 0 to 1, since we want to be in the first quadrant. 0 to 1. Nice thing about the square root and the square is they end up canceling. Bounds from 0 to 1 of 1 minus x squared dx. And so we end up with x minus 1/3 x cubed. We're plugging in 1 and 0. 0 doesn't make any difference, so it's just 1 minus 1/3, or 2/3. That's our final answer. So as far as the cross sections go, you want to write down your formula for whatever you're looking at. Semicircles is the only one you really have to be careful about, because the semicircle, the radius that you have is not your function. Functions end up being the diameter. But for like a square or a rectangle, the side is just your function.